episode where we take a deep dive. Welcome to this episode where we take a deep dive into essential health, safety, and environment concepts. Based on a comprehensive set of 180 interview questions and answers used by HSE professionals worldwide. Today, Chloe and I will break down critical safety documentation, procedures, hazard identification, and control measures that every expert should master.
Absolutely, Liam. This episode is all about clarifying complex topics and sharing practical insights that can be applied directly on site or during audits. We'll cover everything from method statements to fire safety, confined spaces, and even radiography safety. So let's get started.
Let's begin with planning and documentation. The method of statement is a formal document contractors submit to clients. It outlines the general work procedure for a specific job, emphasizing safe execution according to required standards.
Right, and closely related is the work method statement, or WMS. Think of the method statement as the recipe for safe work, and the WMS as the step-by-step cooking instructions. The WMS helps plan and execute work safely and efficiently, detailing the codes and standards for each activity.
That's a good way to put it. These documents are crucial because they align expectations between contractors and clients, ensure compliance, and help prevent accidents by setting clear procedures.
I guess one question that often comes up is, how detailed should these documents be?
Good point. They need to be detailed enough to cover all critical steps and hazards, but also clear and practical so workers can follow them easily. Overly complex documents can sometimes be ignored or misunderstood.
Exactly. It's about striking the right balance.
Moving on, Job Safety Analysis, or JSA, is a proactive tool. It breaks down a job step by step to identify hazards and implement controls. The process involves observing the job, breaking it into steps, identifying hazards at each step, determining control measures, and then implementing those controls during execution.
So it's really about anticipating risks before they become incidents.
Yes. For example, before welding, a JSA would identify fire hazards, specify the need for personal protective equipment, and require a fire watch.
That fire watch role is critical, isn't it?
Absolutely. They monitor the area for any signs of fire during and after the work.
And I suppose the JSA also helps with training new workers by clearly outlining hazards and controls.
Exactly. It's a communication tool as much as a safety tool.
Speaking of control, work permits play a vital role. A work permit is a written authorization for personnel to perform specific tasks like maintenance, inspections, or construction.
Right. And there are several common permit types. Hot work permits for welding or cutting, cold work permits, confined space entry permits, excavation permits, lifting permits, night work permits, and radiography permits.
That's quite a list. How do these permits actually help control hazards?
They ensure proper preparation, authorization, and monitoring before and during the work. So, for example, a hot work permit confirms that combustibles are cleared, fire extinguishers are ready, and a fire watch is assigned.
So it's not just paperwork, it's a critical safety control.
Exactly. It formalizes the process and holds people accountable.
Now, confined spaces are one of the most hazardous work environments. Defined as any space with limited access or egress, they pose risks like oxygen deficiency, toxic or flammable gases, dust, heat, and more.
The safe oxygen level in confined spaces ranges between 19.5 and 23.5%.
That's a pretty narrow window.
It is. Before issuing a confined space work permit, several conditions must be met. Proper ventilation, satisfactory gas test readings, barricades and warning signs, a trained standby attendant, adequate lighting with low voltage electricity, communication means, lockout/tagout if necessary, and lifeline or retrieval systems.
The confined space attendant has a critical role here.
Yes, they monitor entrance, maintain communication, keep entry logs, initiate alarms if needed, and coordinate rescue operations.
What are some common hazards in confined spaces?
Oxygen deficiency or enrichment, toxic gases, fire, falls, electrocution, and engulfment.
Examples include tanks, vessels, trenches deeper than 4 feet, silos, and ducts.
Continuous monitoring and communication are essential to ensure safety in these environments.
Let's talk about accidents and near misses. An accident is an uncontrolled event causing injury, illness, asset damage, or environmental harm. A near miss is an undesirable event with the potential to cause loss but didn't result in injury or damage.
Near-miss reporting is vital because it helps identify hazards before accidents occur, improving safety performance and reducing lost time incidents.
Who usually reports accidents?
Typically supervisors or safety representatives. Investigations involve a team including HSE managers and subcontractors.
And the purpose of accident reports?
To analyze root causes, recommend prevention measures, and evaluate emergency response effectiveness.
On the environmental side, waste management involves safely disposing of processed byproducts after proper treatment to prevent harm to living beings and the environment.
And when dealing with chemicals, the Material Safety Data Sheet, or MSDS, is indispensable. It provides product information, hazards, first aid measures, recommended PPE, storage, and handling instructions.
It's a critical resource for chemical safety and emergency response.
Absolutely.
Switching gears to radiography and radiation safety. Radiography is used for welding inspection via X-rays. Work must stop if wind speed exceeds 32 kilometers per hour or 20 miles per hour to prevent radiation spread.
Radioactivity is the spontaneous disintegration of atomic nuclei, emitting alpha, beta, or gamma particles. Radiation is measured in microsieverts or millirem. A controlled area is any zone where radiation dose exceeds 0.75 millirem per hour.
What safety measures are in place for these controlled areas?
Barricading with warning signs and flashlights, having a competent person survey radiation levels with a Geiger meter, and personnel wearing film badges to monitor exposure.
Only authorized exposed persons who have formal training in sealed source and X-ray equipment should work in these areas.
Think of controlled areas as radiation zones with strict access and monitoring to protect workers.
Now, crane and lifting safety is another critical topic. Types of cranes include mobile, crawler, tower, and overhead cranes. Key parts are the boom, slings, shackles, outriggers, hoists, and load movement indicators.
Safe crane operation requires firm, level ground with pads, fully extended outriggers, certified operators and riggers, load charts and safe load indicators in use, wind speed limits not exceeding 20 miles per hour, and operational anti-tube lock systems.
What exactly is the Safe Working Load, or SWL?
It's the maximum safe load for lifting equipment. Exceeding it risks equipment failure.
And tandem lifts?
That's when two cranes are used simultaneously for heavy or awkward loads. It requires careful coordination and planning.
Planning is essential. A lifting plan includes load calculations, equipment selection, JSA, and load charts to ensure safe lifting procedures.
Excavation and trenching safety is next. Excavation is a man-made cut or cavity formed by earth removal. A trench is a narrow excavation where depth exceeds width. Shoring is a support structure to prevent cave-ins.
Soil classification is key for safe slope design. Stable rock can be vertical at 90 degrees. Type A soil requires a 3 to 4 slope, about 53 degrees. Type B soil is 1-to-1 slope, or 45 degrees. Type C soil is 1.5 to 1 slope, roughly 34 degrees.
Ladders must be within 25 feet of workers in excavation. Excavations deeper than 1.2 meters are considered confined spaces, so additional precautions apply.
That's an important point. Excavations can become confined spaces, which means all those confined space safety measures kick in.
Exactly. Soil classification and proper shoring are critical to prevent cave-ins and protect workers.
Scaffold safety is another major area. Scaffold components include base plates, sill boards, screw jacks, couplers, ledgers, transoms, handrails, midrails, toe boards, platforms, ladders, and bracings.
There are various scaffold types: system, underhang, mobile, bracket, tower, and tube and coupler scaffolds. The tag system indicates scaffold status. Green means safe to use, yellow means use with full fall protection, and red means do not use as it's under erection or dismantling.
Only certified scaffolders can erect scaffolds, and competent supervisors inspect them. Platforms must have a minimum plank overlap of 12 inches. Guardrails should be 38 to 45 inches high, and toe boards at least 4 inches.
Access ladders must be properly angled at 75 degrees, tied off at both sides, not by the rungs, and extend at least 90 centimeters above the landing. Mobile scaffolds must be plumb, level, and moved only when the platform is clear.
Scaffolds should be inspected after erection, before use, after weather events like rain or heavy winds, and at least weekly.
Fall protection systems come in 3 main types: guardrail systems, safety nets, and personal fall arrest systems, which include body harnesses.
Fall protection is required if the potential fall height exceeds 1.8 meters, or about 6 feet. Safety harnesses must support at least 2450 kilograms.
Lifelines must be anchored to fixed points capable of supporting 2,300 kilograms, protected from abrasion, and installed above shoulder height. Proper anchorage and regular inspection are critical.
It's easy to overlook anchorage points, but they're fundamental to the system's effectiveness.
Absolutely.
Fire safety is another cornerstone. Fire requires 3 elements: fuel, heat, and oxygen. Fire classes and their extinguishers are specific.
Class A fires involve ordinary combustibles like wood and cloth, extinguished with water, foam, dry chemical powder, or CO2. Class B fires involve flammable liquids and gases, tackled with foam, CO2, or dry chemical powder.
Class C fires involve energized electrical equipment, requiring dry chemical powder, FM200, halon, or CO2 extinguishers. Class D fires involve combustible metals like magnesium or titanium, needing special metal-type extinguishers.
The Fire Watch's role is to monitor hazardous areas, alert and extinguish fires, and protect people and property.
Hot work safety includes removing combustibles within 10 meters, using fire blankets, having fire extinguishers and fire watch personnel, barricading the area, and conducting gas tests.
A critical note: never use water on electrical fires due to the risk of electric shock.
Risk assessment is about identifying what can go wrong, the causes, and preventative measures. Emergency evacuation plans provide clear guidelines, define roles of fire wardens, and designate assembly muster points.
Head counting ensures all personnel are accounted for after evacuation. In a gas release emergency, workers should move crosswind, then upwind, follow instructions, and avoid panic.
Toolbox talks are briefings to educate workers on safe work rules and specific hazards, fostering a proactive safety culture through communication and training.
Lockout/tagout, or LOTO, is essential during servicing or maintenance to prevent unexpected energizing or release of energy. Locks and tags are placed on isolating devices to prevent accidental operation.
Finally, safety culture and communication involve shop floor representatives, supervisors, and managers discussing health and safety. Communication methods include written notices, handbooks, oral interviews, toolbox talks, and visual aids like posters and films.
Investigations aim to find causes, not assign blame. Proactive monitoring checks compliance before accidents occur. Psychological hazards like mental stress and physical hazards like noise, radiation, and heat also need attention.
Attitude, peer influence, and workplace group behavior play significant roles in safety outcomes. Safety is both a technical and human challenge.
To wrap up, documentation, communication, and proactive hazard control are the pillars of effective safety management. Safety is a continuous process involving planning, execution, monitoring, and culture.
Thanks for joining us in this detailed exploration of HSE essentials. We hope these insights help you strengthen safety practices in your work environment.
Stay safe and keep pushing for excellence in health, safety, and environment. Until next time.